Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9th students of KTS 1E block so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter, the sixth chapter, gravitation. And today we are entering into the session number 2. Maybe 2 more sessions or 3 more sessions will get to complete this chapter, which is the proposed syllabus for test 6. As all of you know, repeatedly we are reminding the test 6 is on 30th December with the syllabus of gravitation, the total chapter, right? The total chapter. Why? Once you check, from my side sound is clear. 1E block. From my side sound is clear. Check from your end only because I can see here. Okay. So the gravitation, the entire chapter is for the test 6, which is scheduled on 30th December. Okay. Now, in last class, that is session number 1, we discussed about what is gravitation and gravitational force. As you all know that when you got the word gravitation, we can recall the Sir Isaac Newton sitting under apple tree. When he sat under the apple tree, apple fallen down. Generally, the people like our mindset will take apple and will eat it. But he thought that why apple fallen down? Why it is not went up or stayed there only? That means there should be some force which is attracting the body towards the earth. And such force which acts between the two bodies is named as gravitational force or simply a gravity. Gravity is nothing but force of earth. So not only that, even other planets also have these kind of force that is comes to know when they are studying about the gravitational force of the earth, right? So all, can you be audible for? Can you hear me, all of you? Other branches, Medchal and Ramnagar. Okay. So such kind of force of earth with which all the bodies are attracted towards it are called gravitational force. So after terming the word, after giving the name to the gravitational force, Newton proposed one law. On what factors this gravitational force depends, right? Simply we cannot say orally, there should be a documentation. So he given the documentation that suppose you have taken 2 bodies of masses. Suppose big one is called M, small one is called M, or you can write a M1, M2 also, right? 2 bodies are there. They are separated by a distance of R, right? The distance between them is R. The distance between their centers you have to take generally R. Then what is told that the force between them, the gravitational force between them is directly proportional to product of their masses and inversely proportional to square of the distance between them. This is a statement given, 2 statements for the Newton's gravitational law. Law of Newton's gravitation. Right? So by combining these two, we get common equation. F is equal to G into M1, M2 by R square. Where the G is introduced here. Universal gravitational constant. As a constant, the value also constant. 6.67 in 10 power 6 minus 11 Newton meter square by kg square. The value of the capital G, which is called universal gravitational constant, which is derived from Newton's law of gravitation. Right? The G value is same for all the planets. The G value of Sun, Moon, Earth, or Jupiter, Mars, wherever you go, the capital G value remains same because that is independent of mass and distance. It does not depend on anything. It is independent on mass of the body, distance between the body, and medium between the bodies also. Whatever the medium is there, the capital G value is same. Right? That's why it is called universal gravitational constant. Clear? So this total explanation is given by Newton's law of gravitation, which we discussed in the last class. Now we are going to learn some more important words. So the factors and everything we have seen already, right? We have seen what is the gravitational force and units are there, value is there, right? All these things we've seen in the last class. Now we are going to know about the synopsis 2. When you enter to the synopsis 2 here, after knowing about the gravitational constant and its value, we have seen gravitational force between the Sun and Earth also. If you know the mass of Earth and radius of Earth, mass of Sun and radius of Sun values are there. Similarly, gravitational between Moon and Earth also we have seen. Okay. Everything we have seen. So it depends on that, the value which is. Now we'll come to second synopsis, that is acceleration due to gravity. That is small g. So till now we have seen the capital G. Now we are seeing the small g. See, force C. The force between when the body is Sun and Earth. Between Sun and Earth, the gravitational force value is given after the calculation. And between the Moon and Earth also, the gravitational force is this much. Gravitational force changes, but the value of G remains constant. Right? The force of gravity changes between the bodies. The force of gravity F depends on the mass of the body, radius of the body. As you know, Sun is having different mass when compared to Earth, very huge mass. And Earth is having the big mass when compared to the Moon. And the radius also difference. Due to change in the radius and mass, the force of gravity changes. But universal gravitational constant same for any case. Okay, Earth and the mass you can see. Earth and the 1 kg mass body, it is only 9.8. When you take the Earth and the first case, 9.8 Newton. So we have taken the G value constant. Mass of the body is 1 kg and mass of the Earth is 6 into 10 power 24 kg. And radius of the Earth is 6.4 into 10 power 6. By substituting value, you get 9.8 Newton. That is the gravitational force between Earth and second body is of 1 kg mass. But when you take the gravitational force between Sun and Earth, Sun and Earth, both are the big bodies only. That case, you get the F value. These many Newtons calculations are not done here. 3.6 into 10 power 22 Newton. 3.6 into 10 power 22 Newton. Heavy. Between Earth, Moon and Earth is 2.05 10 power 20 Newton. F value. The gravitational force between Earth and 1 kg mass is 9.8 Newton. Between Sun and Earth is 3.6 into 10 power 22 Newton. Between Moon and Earth is 2 into 10 power 20 Newton. So F value changes with the mass and distance or radius. Okay. Now we'll come to the second synopsis, second part, acceleration due to gravity. Very, very important. You know acceleration. Acceleration is nothing but rate of change of velocity. What? Rate of change of velocity is called acceleration as per our mechanics. Right? We have derived the formula also. First equation of motion. Rate of change of velocity due to gravity. Suppose I am dropping the pen. The pen, what is the velocity of the pen in my hand? 0. There is no velocity. But when I am dropping, what happened? It is attracted towards the earth with increasing the velocity. That is with acceleration. So acceleration due to gravity is nothing but acceleration produced in a freely falling body due to gravitational pull of the earth. So acceleration produced in a freely falling body due to gravitational pull of the earth is called acceleration due to gravity, whose value is 9.8 meter per second square for Earth. G value of Earth. G value of Moon is 1.67, which is meter per 6 times less. Meter per second square in case of Moon. The G value on Sun is 27.3, 3 times more than the Earth. The G value changes from one planet to another planet. It's not like capital G. Capital G remains constant, but small g varies with the place to place and planet to planet. On Earth, its value is 9.8 meter per second square. Whereas on Moon 1.67, which is 6 times less than, right? So G on Moon is 1/6 of G on Earth. Suppose your weight on Earth is 60 kg, right? But when you go to Moon, it becomes only 10 kg. You feel that you are 10 kg weight. Why? Because of the value of G. You are attracted with the less force so that the G value decreases. But when you go to Sun, if you can, we cannot go to Sun. To go to Sun, your weight becomes 3 times, 180 kg. If you are 60 kg, you can feel that you are 180 kg on Sun, which is impossible, only imagination. Because if you go to Sun, you will become the ash only, right? We cannot bear that heat. So such an acceleration produced in a freely falling body is called acceleration due to gravity, which is denoted by a small g. Small g. Okay. So this is purely because of the Earth attraction, Earth gravity. And this changes from place to place. So on Earth it is 9.8, but even on Earth also it changes from one place to one place due to so many conditions. When you go to height, the G value may become little less. When you go to depth, G value may become very less. When you go to cool places, that is atmospheric conditions like hotness, coolness, they may affect the value of G slightly. It may become 9.6, 9.8, 9.7, maybe approximately 10 also some places. But overall average, it is 9.8 on Earth. But when you go to Moon, it becomes less than 6 times less than the Earth. And when you go to Sun, more than. Like that, you can find out for the small g value of any of the planets by knowing some values. So what is the relation? Already we have seen capital G and we have seen small g also, right? So when you see the relationship between them, so relation between capital G and small g, relation, very, very important formula again. So that is G and G, if you want. Suppose you know the formula F is equal to G M by R square is the one formula. Force. M1, M2, or you can write MM. M is the mass of the Earth. M is the mass of the small 1 kg body. You can write like this. And you know second formula, F is equal to MA, Newton's formula, Newton's second law. Or you can write mg. In place of acceleration, write acceleration of gravity. That is second equation. So both are the gravitational force only, right? So you can write mg is equal to gmm by r square. Correct or not? Yeah. Equating 1 and 2, both are F only. So in place of F's, I replace this one. Equated both. So you can cancel out M, F. So what you got? Finally, G is equal to gm by r square. Right? Or capital R. You know the value of G. Substitute G value. On Earth, suppose Earth you want to find out. 6.67 into 10 power minus 11. And mass of the Earth, we know 6 into 10 power, somewhat 24 something, something value. Then again by radius of the Earth also we know 6.4 into 10 power 6 whole square. By doing all this calculation, we get it value as 9.8 meter per second square. If you want to find for the Sun, G value of Sun, so you have to take mass of the Sun, radius of the Sun. If you want to find for the Moon, mass of the Moon, radius of the Moon, which is already given in the previous slide. By substituting values, you can get G value as for Earth 9.8, for Moon 1.67, for Sun it is 27.3. Like that, you can find the G value of any planet, any body if the masses are given. Okay, that is about the acceleration due to gravity. See given here definition. The acceleration with which a body falls under the earth due to the earth gravitational pull is known as acceleration due to gravity. So already given the expression is given here. G is equal to gm by r square. With this expression, we can find the value of G either on earth or on sun or on moon. Everywhere you can find out the value of small g. But its value on earth is 9.8 approximately. A value on moon is 1.67. You can note down this. G on earth. You can note down in notebook. Earth is 9.8 meter per second square. You know that value. Second, value on moon. Right. It is 1.67 meter per second square. Third one, value on sun is 27.3 meter per second square. Note on this value. And fourth one also relation. The value on moon is 1/6 of the value of earth. Very important relation. We can solve some problems based on this. Whatever the weight is there on earth, when you go to the moon, for example, I tell your weight is 60 kg when you are checking with the weighing machine at home. So when you go to the Birla planetarium, if you go anywhere, different states, different places will have. There is a weighing machine is there, which is connected to moon's gravity. If you go and check your weight, you found only 10 kg, you will get the slip 10 kg. It doesn't mean that your weight becomes 60 to 10 kg by reaching the planetarium. Thing is, it gives the value with respect to your weight with respect to moon's gravity, which is 6 times less. Your weight on earth divided by 6 will give weight on moon. Your weight on earth into 3 times approximately will give weight on sun. Okay. So by the way, you can find out the value of G either on earth or moon or sun or any other planet by knowing the masses. We know the formula. G is constant for everything. By knowing the mass of that and radius. By knowing these two values, we can find out the G value at any place or any planet. If you know the Mars you want to find out. Mass of the Mars and radius of the Mars, if you know, you can find out. Or Jupiter, you can find out. Heavy mass body. Everywhere, any planet, you can find out the value of small g, which is varies from place to place, whereas capital G is same for everyone. That's why it is called universal gravitational constant, right? So before going for the further explanation, let me show you one video on the same. Okay. After seeing video, we'll go for the conclusion of today's topic. Okay. So we discussed today only about the acceleration due to gravity and their factors.
हम पढ़ेंगे एक्सेलरेशन ड्यू टू ग्रेविटी।
तो आ गए आप। इस वीडियो के अंदर हम एक्सेलरेशन ड्यू टू ग्रेविटी के बारे में जानेंगे। इस वीडियो के लास्ट में
So just a minute, it is coming in Hindi. Okay.
In the UK, there's an amazing study in life balance.
My program is very interactive, which will enhance my career prospects in so many ways.
Each experience while studying here has helped expand my horizons.
Anything is possible
when you study in the UK.
In this module, you will learn about acceleration due to gravity. When you throw an object up, it comes down due to gravity. When an object, such as a boulder, is pushed from a height, it falls to the earth. Such an object is said to be in a free fall. An object is in free fall when it falls to the earth under the sole influence of gravity. a fruit falling off a tree, or a sandbag thrown off a hot air balloon hurtles towards the earth in a free fall. However, a parachutist is not in free fall, since the parachute reduces the effect of the gravitational force of Earth. A body under the influence of Earth's gravitational field can be a body dropped from a certain height, like a ripe fruit falling off a tree. A body thrown vertically downward from a certain height with some velocity, such as a ball thrown down by a boy from the 5th floor of a building, or a body projected vertically upward. For example,
Thrown up.
a stone thrown vertically upwards. Objects in free fall move only in vertically downward direction. However, their velocity changes as they fall. A change in velocity results in acceleration. The acceleration of a freely falling body due to the gravitational force of the Earth is known as acceleration due to gravity. Acceleration due to gravity is denoted by the small letter g and is measured in meter per second square. How can you determine how long it will take for an object in free fall to reach the Earth from a specific height? To perform such calculations, you need to know the value of acceleration due to gravity. Let us now derive the expression for acceleration due to gravity, g. Consider a freely falling object of
You have seen G
mass
value of Earth,
m.
mass we placed, 1 kg mass.
Let
Capital M is the mass of the
the
Earth.
capital letter M denote the mass of Earth. D be the distance between the free-falling object and the center of the Earth.
Center of the mass to the
And R be the radius of Earth. Since the object is in free fall, the gravitational force F on the object is the product of its mass m and the acceleration due to gravity
Newton's second law.
g.
F is equal to ma becomes F is equal
Let's
to
call
mg.
this equation 1. The gravitational force F between the Earth and the free-falling body can also be calculated using Newton's universal law of gravitation. F is equal to g multiplied by m divided by d square. When the object is near to or on the surface of the Earth, the distance d is taken as equal to the radius of the
We
Earth.
try to understand it. When it touches the surface of the Earth,
Let this be equation 2. By equating 1 and 2,
I have already shown for you.
we can calculate the acceleration due to gravity as g is equal to g multiplied by m divided by r square. Since the Earth is not a perfect sphere, its radius is maximum at the equator and minimum at the poles. Hence, the acceleration due to gravity is greater at the poles than at the equator. This difference is negligible for bodies on Earth. To calculate the value of acceleration due to
Formula you say na?
gravity,
I derived.
g we need to substitute the values of universal gravitational
G value is
constant
constant, you can see.
G, mass
Mass
of the Earth
Earth,
M, and radius
radius
of the Earth R
by substituting get 9.8.
in the expression we derived. On substituting and simplifying,
Approximately 9.77 or
we
approximately
find
9.8.
that the value of G
On surface
is
of Earth.
approximately 9.8 meter per second square. Acceleration due to gravity at a place on Earth is the same for all bodies irrespective of their masses. Let's use two identical objects with
Very
different
important
masses
observation made
to
by
verify this statement.
Galileo
Drop a metallic ball
and
and an identical wooden ball from a height. Do you notice that both reach the surface of the Earth simultaneously? Since the mass of the metallic ball is greater than that of the wooden ball, the force of gravity on the metallic ball is greater than that on the wooden ball. However, it doesn't seem to make the metallic ball fall faster than the wooden ball. This proves that acceleration due to gravity on Earth is the same for all bodies, irrespective of their mass.
right. It's a very interesting conclusion given there that we'll discuss about that. Okay. So clear explanation about the what is the G value. So what example they told it that taken is, so the value of G is same on the any mass. For example, we have taken the metal ball and wooden ball. Both we have taken. When you are dropping both of them, because on surface, we know on surface of Earth, the value of G is same. So the value acting on the both bodies are same only. When you are dropping both of them, both should reach at same time. But what we observe generally is metal ball reach far faster than the wooden ball, right? Why? Because of the air resistance. So air resistance will affect it. If there is no air resistance, both will reach same time only. For that only, Galileo performed experiment from Leaning Tower of Pisa. So coin, 1 rupee coin and feather he dropped. When coin and feather dropped from the Leaning Tower of Pisa, coin reached first, later feather. Why? Because of the air resistance is more on the feather than coin. But when both this coin and feather dropped from vacuum tube, he created a vacuum tube and it dropped coin and feather. What he noticed is both will reach the bottom at same time, irrespective of the resistance of air. What? Irrespective of air resistance, acceleration due to gravity is same on any bodies towards the Earth gravity. Mass may be more or less, material may be different or same, but the value of G on Earth is remains same. Both the bodies reach at same time if there is no air resistance. So due to air resistance is more on lighter bodies than heavy bodies, maybe heavy body reach first than the lighter body, right? So with this, what we are clear? We are clear about the what is G. G is nothing but acceleration produced in a freely falling body due to gravitational force of the Earth, right? Then G value on Earth is approximately 9.8 meter per second square. G value on Moon is 1.67 meter per second square. G value on Sun is 27.3 meter per second square. And the G value can be calculated by Gm by Me by Re square. That is Earth, capital, you can get Earth. So this value for the Earth, Ge is equal to. So Gm you want, you can get Gm is equal to Gm by Rm square. Sun also same. If you know the value of mass and radius of the Earth, Sun and Moon, you can find out the G values and you can find them as 9.8, 1.67 and 27.6. So as you can see here, relation also, G value of moon is 6 times less than the earth. G of 6 by 6. Whereas G value of the sun is 3 times more than the earth approximately. So that means even earth also, on surface of the earth also, there are some factors which influence the G value. It may be 9.8 meter per second square, but when you go to some height, when you go to the deep into the mines, or when you go to some cool places, or when you go to some hot places, so the value of this slightly varies. It may from 9.6 to 10. The slight variation is due to the surrounding conditions. But generally it is 9.8 on surface of the earth. Right? Clear? This is a clear picture about the value of G, that is acceleration due to gravity. Here, there is a variation of value of acceleration due to gravity is given here. Clearly, you can find out the value of G on sun and the moon. And by finding what we have seen is, these are 6 times. Okay. So value of G on the surface of the sun. Right. That is not G, small g or right here, capital given. Change that as small g. So this is, we can find finally, it is 1/6 of G of earth. G of moon is 1/6 of the G of the earth. Okay. So acceleration due to gravity on earth of the, right, that is 1/6 value. So all these please change this as a small g, it's not capital G. In material also you can change. There is this is small g, this is also small g. Right? So as the shape of the earth changes, so for example, shape of the earth is elliptical. The G value on surface is 9.8. Right? When you go to the center of the earth, as you are coming deep, at center of that becomes 0. There is no acceleration due to gravity. So as you are moving into the earth crust, the value slowly decreases and finally becomes 0 at the center of the earth. So the G on poles is maximum. Poles is maximum. That is G value on equator is 0 or minimum. So as you are moving from the pole to the equator, the value of G becomes 0 from 9.8. 9.8 to 0. That also you can calculate. There is a mathematical formula for calculating the value of G as you are moving from the surface of the earth to the center of the earth. But at center of the earth, the value is 0. That's what is given here. Equator is given by the formula as well as pole is given. At poles, the value is maximum. At equator, value is minimum or even 0 also. Means the value of G changes, small g. Capital G remains same, but small g changes from place to place and planet to planet, as well as you moving into the earth crust also. When you go into the earth crust, into the deep into the earth crust, or when you go to away from the earth crust also, the value of G varies from 9.8 to even 0 when you reach the center of the earth. Right? Similarly, there are so many other factors also there, variations, value of depth below. When you go to the depth, when you go to the height, that is given here. As you move to the height also, the value of G changes. When you move to the depth also, the value of G changes. And the formulas are given, which we can derive from the same formula. You can see here. So variation of the value of, see, make it or small g only everywhere. Please, in your material, change this capital G as small g. So it's a small g, not capital G. 3-4 places is printed as capital G. See here. Suppose this is our earth, right? So this is the radius of earth. Radius is this. Okay. So we are placing some object here, mass of M. Earth mass is capital M. Right? We know the formula G is equal to Gm by R square. Right? So R is here. The radius of this body also to consider small r. Then what is the total? R becomes here R plus R. What he wrote here, R plus H. The body is at a height of H. You have taken some ball, rubber ball, at a height of H from the surface of the earth. Then the total radius becomes what? G is equal to Gm by R plus H whole square. Right or not? This is R, radius of the earth. and h is the height of the body above the surface of the body. From that you get the formula, right? Gm by r plus h, that is g on earth. Okay, so what is original g, you can find out. So this is g on earth, original g is gm by r square. Divide both of them. When you are dividing them, gm cancel. So what will you get here? Ge by g is equal to g is this, by g is given by, we'll get the value gm by r square by r by h whole square. Right, from this you can get the formula. So is greater less than 1, the value is less than 1, because r square by r plus h whole square, something plus whole square gets. So what is the meaning less than 1 means this value decreases. When you go to the height, the g value decreases from 9.8 to some value. As much as height you go, the value of the g decreases. So as it is less than 1, it indicates that decreases. So try to understand here simple concept. When you are at a height of h, small h from the above surface, we got the g by the ratio of g on earth by original g is given by is less than 1. Less than 1 indicates the value of g decreases. Similarly, when you go to depth also, you get sign. So okay, so we'll discuss came in the next class about the what factors apart from the depth, height, what are the other factors influence the value of g, like poles, equator I already told. At poles the value of g is maximum. When you reach the equator, value becomes 0 or minimum.